Hi, still uh, on the medium access control technique, and now we will continue to explore the scheduling scheme. Yeah. Okay, we have discussed about the medium sharing techniques using dynamic medium access control scheme and random access, yeah, on the uh, previous video. And now we will continue to discuss about the scheduling, still dynamic medium access control, yeah, but with a scheduling scheme, and we will continue to static channelization on the medium sharing techniques. Now, the control access or scheduling can be implemented using three big scheme, yeah, that is reservation, and then polling, and then token passing. Nah, in the reservation scheme, before a user can send a data, they have to reserve the slot. In this illustration, yeah, for example, user 1, 2, 3, 4, and 5 in this time don't have a frame or information to send, so they are not reserved, they don't reserve to send a frame. Now, in this illustration, for example, station 1 has reserved a time slot, and after this, station 1 can send a data. Now, with reservation, we can avoid the collision because the user only send a data after they reserve. So we can avoid the collision, yeah, because every user only send a data based on their reservation. And then polling. Nah, using polling scheme, there are two models, yeah, of polling scheme, yeah, centralized and distributed polling. Now, using distributed poll, no primary and secondary nodes. Stations have a list of known polling sequence that is created according to several protocol. So the station with the highest priority will have access right first. So they can send a data first, yeah, and then the next access rights will give into the next station, and the next station will send a data when they have a right for access. Now, using centralized polling, there is a primary station and secondary station, and every control is done by a primary station, and the secondary station send or receive a data based on the command from the primary station. Nah, this one, yeah, for example, a select and poll function in the polling access method. So if primary want to send a data, it will send a select signal, for example, to B. And then when B give a response with ACK, primary send a data. Now, if the primary want to receive a data, the primary also check it one by one to station A and station B. The primary will send a pole signal, for example, to A, yeah? And if A if A doesn't have a data to be sent, they will send not acknowledge like this. And then the primary will send the other pole signal to B, and if B have a data, B will send a data to a primary. So every activity is based on the primary node control, yeah. Now, the third mechanism is token passing. So there is a listen mode and transmit mode. In the listen mode, every node have to pay attention to the every arriving bits or frames, yeah, and checks the destination address. If they receive the data with their own destination address, so they will take a data for the self, yeah, and then the other state is transmit state. So when a station have a churn, yeah, have a churn to transmit a frame, then they send a data. So they have to listen and then transmit if the time is they turned, yeah. This one is the steps. Before they can send a data, the user have to wait for the token. And if the token is come, so that is the sign that they can that they can, yeah, send a data, and then they send a frame. Now, if the data is successfully sent or the allocated time is expired, the token is sent to the next node. Nah, that's all about the scheduling, yeah. So as the reason, we can say that for scheduling we have 3 schemes, yeah. That is reservation, and then polling, yeah, and token passing. This method is scheduling, is use a scheduling idea, yeah. Now, and then we have the other medium sharing techniques, that is static channelization. Now, on the channelization, we have 3 protocols here: frequency division multiple access, or FDMA, and then time division multiple access, or TDMA, and code division multiple access, or CDMA. Now, using FDMA, the transmission medium is divided into some number of frequency bands, yeah, and every user is give a certain frequency band, and then they only send a data using that using the exactly frequency band that they have get, yeah. Now, for example, user user 1, for example, only send a data using this frequency. User 2 only send data using this frequency. And user 4 and user 3 also have certain frequency. That is FDMA, yeah. And then TDMA. Now, using TDMA, the turn of user for sending data is divided based on time, yeah, based on time. So, for example, on this one, on this, yeah, for example, the first second until 5 seconds, for example, it's for user 4, and then from 6 until 10 seconds, it's for user 3, for example. So every user have a certain portion based on the time, yeah. The frequency is same, but the time is different for every user. And then CDMA, or code division multiple access, it uses specific code, yeah. And the receiving station have to do some steps, yeah, to get the original information, yeah, based on the certain codes that they use, yeah. So before it send, for example, user 1, because the code for user 1 is C1, so the data have to calculate or have to process using the code. And then this one is the code for user 2, and for user 4, and for user 3. So the data is sent and at the same time and using the same frequency but different code. Now, okay, so every method of medium sharing scheme, yeah, is finished to explore, and now we will go to the physical addressing, that is called MAC address, or this one is physical addressing, that is exists in layer 2, physical address, yeah. Now, the MAC address is consists of two parts. The first part is determined by an organization, and the second part is determined by the manufacturer. So the first part is give us the information about the organization or the industry, and then the second part is a specific number, yeah, that is generated by the manufacturer. And MAC address consists of 48 bits. If you check your laptop and then you go to the terminal and then check the address, you will find that there is a physical address like this, and this is MAC address. And this part is inform us about the industry, and the second part is inform us about the specific code that is generated by the manufacturers. So we will know the tools or the tools or everything that is produced by, for example, Cisco or Dell or Linksys, because they have specific number on the first part of MAC address. and we cannot change, yeah, we can't change the MAC address. So the physical address is static, and it can't to be changed. Yeah, it's different with IP address. Now, to broadcast a packet, it will put MAC address like this, and it inform the router that the packet have to be broadcasted if the packet have this MAC address. Now, we also have ARP protocol on the network, or address resolution protocol, to map the IP address into the physical address. So if A want to send something to for example, this on this network here, for example, A want to send packets to B, so A will broadcast, I have a packet with the IP address blah blah blah, so who have this IP address, and please give me information about the MAC address. After A get the MAC address, so it will forward the packet to the exactly user with the MAC address. Okay, this one is the example of standard here of the network of the wireless line. Yeah, not wireless, not only the wireless LAN, but the protocol that we can use on the network, like there's a token bus protocol, and then broadband LAN using coaxial cable, etc. So many technology that exists, and it have a certain standard. Yeah. Now this one is example of IEEE 802.3 or Ethernet protocol. The standard will give like the specification, yeah, the specification of communication steps. Communication method. For example, Ethernet can use physical layer medium alternative like 10^5, 10^2, or 10^T, etc. with specific character. And then these are the fields. These are the fields on the frame, yeah, on the Ethernet frame format. So there is a physical layer header here, and then you know that this destination address, there is source address, length of type, etc. And this one is the original data, CRC. We have explored this on the week 4, yeah, on the week 4, yeah, about CRC. And then these are the other standard of IEEE standard 802.11 or WLAN, yeah. And then this one is WLAN architecture. So on the WLAN architecture, there are physical protocol here, and then MAC address is also defined here on the layer 2 or data link. Now, please pay attention to the frame format, yeah. So from the frame format, we can't get the information that there are more than one address here, yeah. Address 1, 2, 3. There are 4 addresses here. So not only 1 or 2, but there are 4 fields of address. Now this one, yeah, 4 address field, and each of field consists of 6 bytes long. Now, so not only IP address, MAC address is also put on the frame format, so we need more than one address field here, yeah. So if there are user B here and there are user A here, and they want to, for example, A want to send a data, so only 2 address field that is used here. And then on this illustration, if A want to send a data to B, but they use different they are on different BSS, yeah, and we need access point here as a distribution system, so we need more than one address here, address B and A, and also address of access point here. And also here they use 3 fields of address, and in this illustration they use 4 fields of address. The address is for A, B, and also the address of access point in this network. So for MAC address itself, MAC address for WLAN or Wi-Fi, yeah, it's some variations. So there is a access point address here, and then source address and receiver address is a common information, yeah. You know that it's important to put on the frame, but actually also there is access point address here, and then BSS ID, for example, yeah, or basic service set identifier address that we have to put. It's have a relation, yeah, between access point and BSS ID, yeah. So if we need to connect the infrastructure network to access point, this address need to put BSS ID or the name of the access point, yeah, and then source address and destination address. And this is a different frame format between Ethernet and WLAN. So if we use WLAN or Wi-Fi and we also use Ethernet, they have different format like this. In the WLAN or Wi-Fi, there is 4 address field, and on the Ethernet we only have two field of address, two field of a MAC address. Okay, so these are the reference. You can search the books, or you can also find the other reference that is relevant with the course. Okay, thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.